Scientists finally did it. They've discovered the strongest evidence yet that an ocean beyond Earth could support life. Maybe. To fully understand what they found and what this discovery means for you, let me take you back in time. But I'm not just going to take you back 1 billion years. We're going to start much further back than that. Billions of years ago, a moon orbiting Jupiter wasn't just a frozen, lifeless ball of ice. Beneath its surface, it had a vast liquid ocean, chemical energy, and conditions that could rival the deep oceans of Earth. Back then, and maybe even today, Europa might have been one of the best places in the entire solar system for life to take hold. So let's start at the beginning, around 4.5 billion years ago. Europa formed alongside Jupiter and its other large moons from the same swirling disk of gas and dust that built the rest of the solar system. Pieces of ice and rock clumped together into a small world with a rocky core, a possible layer of liquid water, and an icy outer shell. This moon was bombarded constantly, just like everywhere else in the young solar system. Fast forward to today, and Europa is a moon locked in a constant gravitational tug-of-war. It orbits Jupiter in a slightly elliptical path, and because of that, Jupiter's massive gravity squeezes and stretches Europa with every single orbit. This is called tidal flexing, and it generates enormous internal heat, the same way bending a paperclip repeatedly makes it warm. That heat is the reason scientists believe Europa has remained geologically active for billions of years, long after a moon of its size should have frozen solid all the way through. All that internal energy created the conditions for something extraordinary. A liquid ocean, sealed beneath an icy shell, kept warm, not by the sun, but by the relentless pull of the largest planet in the solar system. In 1979, 2 NASA spacecraft called Voyager 1 and Voyager 2 flew past Jupiter and gave humanity its first real look at Europa. What they saw was a smooth, icy surface crisscrossed with strange, reddish-brown lines stretching for thousands of kilometers, like cracks across a frozen lake. This was the first hint that something was very wrong with the assumption that Europa was just another dead, icy rock. For that kind of activity to keep happening, something underneath had to be flexible. Something underneath had to be liquid. Then, in the late 1990s, NASA's Galileo spacecraft arrived to study Jupiter and its moons up close, and what it found changed everything. Galileo carried a magnetometer, and as it flew past Europa, something strange happened. Jupiter's own enormous magnetic field was inducing a secondary magnetic field inside Europa itself, something that requires a layer of electrically conductive material close to the surface. If Europa had a layer of salty liquid water close beneath its surface, that water would conduct electricity and respond to Jupiter's shifting field by generating its own weak magnetic signal. And that's exactly what Galileo detected. Scientists confirmed Europa almost certainly has a global, salty ocean hiding beneath its icy crust. Well, so what? Keep in mind, an ocean isn't just water. Salty water means dissolved minerals. Dissolved minerals mean chemistry. And chemistry, combined with energy and time, is exactly the recipe that may have started life right here on Earth. Now, not long in cosmic terms after Galileo's discovery, scientists started looking even closer at what was happening on Europa's icy surface. In 2005, NASA's Cassini spacecraft, while studying Saturn's moon Enceladus, found something that made researchers immediately think back to Europa. Enceladus was venting massive plumes of water vapor directly into space from cracks near its south pole. Confirmed proof that an icy moon's ocean could erupt right through the surface. If Enceladus could do it, scientists started asking whether Europa could be doing the exact same thing, just on a larger, harder-to-detect scale. In 2012, using the Hubble Space Telescope, scientists detected what appeared to be plumes of water vapor erupting from Europa's south polar region, rising more than 200 kilometers above the surface. The signal was faint and inconsistent, appearing in some observations and not in others, which made many scientists cautious about confirming it outright. This discovery started with Hubble watching Europa pass in front of Jupiter, looking for the faint absorption signature of water molecules silhouetted against the planet's reflected light. Astronomers spotted hydrogen and oxygen, the building blocks of water, in patterns consistent with material erupting from beneath the ice and reaching surprisingly high into space. These plumes, if real and active, could be Europa's ocean venting itself directly into the vacuum of space, giving us a way to sample an alien ocean without ever having to drill through kilometers of ice. Yeah, that's right. An actual sample of ocean water, just floating there for a spacecraft to fly through. That's what's at the core of the excitement around this discovery. When we look at these plume detections, we could be looking at our easiest possible chance yet to directly test the chemistry of an alien ocean. Now, one thing our current spacecraft can't do is just casually fly down and scoop up a sample whenever we want. Which is fine, because there's already a mission built specifically for this. NASA's Europa Clipper launched in October 2024 and is currently on its way to Jupiter, expected to begin its detailed study of Europa in 2030. Unlike Galileo, which only caught brief glimpses during a handful of flybys decades ago, Clipper is equipped with instruments specifically designed to map the ice shell's thickness, search for those elusive plumes directly, and analyze the chemistry of anything venting from below. If Europa's ocean really is venting material into space, Clipper could fly directly through one of those plumes and sample it without ever touching the moon's surface. It's true, even with everything we've found so far, it's very unlikely we'd find anything beyond microbial life, if anything at all. And while Hubble has provided tantalizing hints, we still need a dedicated mission flying close enough to confirm what's actually happening. Getting confirmation is a complicated process. NASA built Clipper with radiation-hardened electronics, specifically because Europa sits inside one of the most intense radiation environments in the solar system, generated by Jupiter's enormous magnetic field. Until Clipper arrives, we won't know for certain whether Europa is actively venting its ocean into space today. But we do know that this moon has remained geologically active for billions of years, while many similarly sized icy bodies elsewhere in the solar system froze solid and went quiet long ago. As Jupiter's gravity continues flexing Europa with every orbit, the ice shell keeps cracking and healing, evidence visible in those reddish lines first spotted by Voyager decades ago. And here's something cool to think about. Some scientists believe Europa's ocean may contain more liquid water than every ocean on Earth combined, despite the entire moon being smaller than our own. If life exists in that ocean, locked away from sunlight for billions of years, it would have to survive entirely on chemical energy, similar to organisms found near deep-sea hydrothermal vents on Earth. There's a real possibility that the deep ocean floor of Europa, heated by the same tidal forces that keep the ocean liquid, hosts hydrothermal vents of its own, an environment eerily similar to where some scientists believe life first began on our own planet. But I'm getting carried away now because full confirmation is still years away. While Earth has been teeming with complex, visible life for hundreds of millions of years, Europa remains sealed beneath 25 kilometers of solid ice, its secrets locked away from direct observation. Without Clipper's data, we're still working from inference, magnetic field measurements, plume detections that don't always reappear, surface cracks that suggest movement below. It's compelling evidence, but it's not the same as direct confirmation. The search for life on Europa is going to get harder before it gets easier, in a strange way. Every spacecraft we send is decontaminated as thoroughly as possible, specifically so that if we do find organic molecules or potential biosignatures, we can be reasonably confident it isn't contamination we brought ourselves. That carefulness matters enormously for a discovery this significant. Europa Actu. Oh look, new plume data is coming in. That's not ominous at all. Maybe one day a future mission will land directly on Europa's surface, drill through that ice and drop a submersible into whatever is waiting below. But that's a story for another video.